Hi, I'm following along with Paul McWhorter's Raspberry Pi lessons, and we're on number 10 this week. He really didn't have any homework for this one, but week 9 he gave um, homework of creating a two-button up and down button to increase and decrease the uh, uh, LED's brightness, by using the push buttons and PWM on the buttons. I did lesson 9 homework, but I did the traditional linear way where, you just have increase it by 10% or 20% or whatever each time. And in lesson 10, Paul introduced the idea of logarithms because we really don't, our eyes don't react to the LEDs in a linear way. The logarithmic way is really a better way of addressing the brightness. So I had made those changes that Paul suggested and followed through the math on doing logarithms and stuff like that. And I just didn't think it was worthy of a video just to change that. But I'd follow along with everybody else that watches Paul. And there's a fellow in here named Brian. And he actually had he did the homework for it. And he came up with this where he's using 5 LEDs and increasing the brightness on the first one until it's all the way bright, and then starts on the second one and increases it in turn and goes through all 5 LEDs like that. He likens it to filling a bucket and then having the overflow into a second bucket and then a third bucket as they fill up. I thought that was a pretty cool idea. And when he was discussing his code, he said, that he thought there was a better way of doing it. He had a lot of if statements, nested if statements here. And he said he thought there was a better way of doing it, but he hadn't really put his mind to it yet. And he said he might come up with a better way. And so myself and Charlotte in the comments were both saying, yeah, we thought there might be a better way of doing it using math. And Charlotte also made a comment to one of mine and then also posted some code of her way of addressing that problem. And so I thought, well, that might be worth trying out and coming up with a video on. So I actually have figured a way of doing it. There's lots of different ways of doing it for sure, and nothing wrong with the way he did, but Brian was saying that he thought there would be a better way. So I don't know whether it's better or not, but I came up with a different way. So I'd like to go ahead and show you what I got going on here. So if you go back to my lesson 9 homework, a lot of this is copy and pasted from that, but adding some extra LEDs in the math to do the LED lighting of each one in turn. So we're just importing the Raspberry Pi, the GPIO library, setting some pins for, actually this LED pin could be left out. That's a leftover from my last one. So that's not even needed right now. But we have our button numbers for the button to dim it and the button to brighten it. And we're keeping track of our steps by doing just with a variable called lead step. We'll skip the function for right now, but anyhow, this part down here, I'm using the built-in event detect rather than detecting the new presses and everything. You can go back to my last video and if you want to understand what I'm doing with that. But this is all the part for the buttons, pull down and all that. And with the event detect, you exit it. Everything happens with interrupts and stuff like that when it detects the events. So we actually can come down here and do a just a input blocking function, and then when we finally quit, we can clean up our GPIOs. So basically that's all we're doing that on down in this section here. What we did up here is we have making a list of our pins that we're using for our LEDs. This goes back to what Paul was showing us in the binary number, so you can make a list of them, and you can actually just, when you do the setup, you can create those import the whole list to GPI to the setting it up as an output, so you don't even have to iterate through them. I guess it does it in the library, it iterates through them. Again, we're set our mode as BCM because we're using the cobbler type thing to attach to our breadboard. Now down here is where we get into where we're doing the setting up our PWM for each of our LEDs, and Brian had shown how you could make a list of PWMs. So Python is quite strong in this section because it'll allow you to put almost anything into a list, and there are a list of PWMs are in there. And I decided to use list comprehension so that it's making the list LP for all the numbers in lead pins. So for each one of these, it's making pulse PWM for it and putting it in a list. So that's kind of cool. You can do all that in one line, but then you got to start them, and there may be a one line opportunity to do that with list comprehension, but didn't spend enough time on it to figure it out. So I just iterating through it. So you want to get the index number, so for each one of those. So to do that, you use this enumerate thing, and that gives you an index as well as this X that we don't need. So we're going through our indexes and we're starting them all with a 0 brightness, so that we're doing that. So that's kind of cool that you're able to set them all up without having to, do each one separately. And I think Charlotte was pointing out that by doing the math, the way Brian did it, if you added more LEDs, you'd have to add more statements. And the same way here, it doesn't really matter how many LEDs you got, the same thing will take care of 1, 2, 10, and as many pins as the Raspberry Pi has. It will allow you to do that on. So that's kind of cool. So I think that covers everything down here. Like I said, the goes down here, and then we're waiting for our button press function. Every time it detects a rising button, a button press, it's going to go to there. So we'll go back up to here, and like I said, this very first part all the way down to here is same as my last video, so I'm not going to go into that. But basically, your button presses decrementing or incrementing your LED step. And so we're actually, the way I do it, I'm doing 20 steps. So that's 4 steps for each LED PWM brightness, and 5 LEDs. So 4 times 5 is 20. So we're counting up to 20. And I don't think I did go into this down here, the calculated log values. Rather than doing the math inside the code, I just did it by hand outside and came up with these 4 numbers plus 0. So I think it was we were 3.12 or something, and I just took whole numbers, because it really, not that critical. I just took whole numbers that compared to that. I think this was 9 point something, this was 31 point something, this was like 98, so I just said make it 100 when you did the actual math. But this is close enough to we're not going to know the difference. So anyhow, so we'll go back up to here. So we got those steps, the log value steps that we are going to work on when we're doing it. But anyhow, we're getting our step count, and this is constraining it to between 0 and 20, and we're printing out whatever step we're on so that we can keep track of that. Okay, and then we want to keep our LED step. That's a global variable that we're using up here, so we want to keep that pretty much solid. So we're going to do some math down here on that number. So we need to, I made a temp step value that I can do math on. Again, we're iterating over the number of our LEDs. So we got 5 LEDs, so that's going to loop through here 5 times for each LED. And what we're doing is, if our number is larger than 4, then we know that that bucket is full, so to speak, and that LED will be full bright. So we're doing the index here, so we're making that one, changing it to full bright. And then before we leave the for statement, we're going to subtract 4 from it so that we can check the next LED in the line with that number taken off. So we're going to go down, and we're skipping this for the time being. So we're going to say, like, let's start out with our number is our lead step is at 7 at this point. So we're temp step becomes 7. So is 7 greater than 4? Yes. So it's going to make the first LED in line full, and then it's going to subtract 4 from the temp step. So temp step is now equal to 3, and it's going to go back up through here and do the 4. So it's going to index to the second LED. And so this time through, temp step is only 3, so it's not going to pass this if statement. So it's not going to do this. It's going to go to the else. And so what we do now is the same way. Our index, our LED that we're working on, we're going to change the duty cycle to our values down here, our log values at whatever we got. So we got 7, or we had 7, so we're at 3. So we're going to be log values at the 3rd position, or position number 3. So that's going to be, this is 0, 1, 2, 3. So it's going to be, your duty cycle is going to be 32. And then, so that second LED is going to be 32, which is, 3/4 bright. And then, so we got that. But then we have to we're going to be cycling through, even though we had that. Once we get into this else statement, we know that all the LEDs above it are going to be off. So what we do is, we go ahead and make our temp step 0, and then it'll cycle through the rest of the LEDs. So if this is 0, it's going to come up here to the if statement, and it's less than, it's not going to be greater than 4. So it's going to go right down to here. But our temp step is now 0. So we're going to be 0 each time through here. So for the third LED, fourth LED, and fifth LED is going to be 0. So it's going to cycle through to make sure that they stay off. And we're setting it up each time. So I guess that's as good an explanation as I can give. So I guess the next thing to do is to go ahead and run this code and we can see it working. So again, we're going down here and we got Q to quit if we wanted to. And then we're going to increase our numbers. So we're at 1, 2, 3, 4 is the brightest. And now we're going to go to the click it again, and it's going to keep that bright. And the next one's going to light up. 5 is going to light up that one a little bit less, or just one step. And then you got 6 and 7. And see, that's where we were taught as we went through the code. That's where we did. And you got one at full brightness, one at 3/4 brightness, and the other 3 are off. So we'll just go ahead on up to 20. 8 is both of them full brightness. 9 we started there. 10, 11, 12. And then we start on the next one, 13, 14, 15, 16. And then we go 17, 18, 19, 20. And then our constraint comes in. If we keep trying to go up, nothing happens. It stays at 20. But then as soon as we go to down, it recalculates each time through. Each time it gets a button press, it recalculates all of them. So it knows that 19 is the number that you're iterating over. And we're down to 16. So there 4 of them are up full bright and the other ones. So we'll just go ahead. 12. 9 shows 8 and off. 7, 6, 5, 4. And we're off again. Anyhow, I thank Paul for definitely for turning us on to the logarithmic way of doing that. That was a big help. And I want to thank Brian for giving me a little bit of a push to I liked his idea of having 5 LEDs and gave me the push to try to figure out a different way of doing it than he did. And glad that we have that small group. Like I say, Charlotte was in there as well with her ideas, and hope she posts a video of what she came up with for it. And like I said, so we ended up with like what we got 37 lines of code to do that. So, but basically everything happens in the button press function here, and by iterating over it and using the math, you're able to cut down on the number of code. And like I said, you got the same number of lines of code, whether you have 5 LEDs or 15 LEDs or how many ever pins the Raspberry Pi has, that you could work the same number of code if you had it wired up that way. Anyhow, thanks again for all you do, and thanks for the community that we have here. Take care.